In this video, I'm going to teach you how to solve this question. It says find the transfer function of the network shown in the figure below. So, solution. Now drawing out the figure. This is the figure. This is the input voltage across the terminals. This is the inductor, resistor. So this is R1 and this is C and this is R resistor, the resistor 1, capacitor, inductor. So I'm still going to use method of mesh analysis to also solve this question. So like I said, let's call this current 1, current 2 flowing in mesh 2, current 3. So now current 3 is equal to 0, but we are going to input it after finding the equations. So using mesh analysis, like I said before, the reason why I3 is equal to 0 is because for when you see an open circuit where the input is open, the output is open, the input is assumed to have an ideal voltage, so it's not actually open, but the output is open, so the current in the output is 0. Now using mesh analysis, because that's what I like using mesh analysis, for the first mesh, like I said, since it's clockwise, moving from negative to positive, you have a positive input voltage minus arrow I1 of t, that's the voltage drop across the resistor, and across all circuit components is always negative for mesh analysis, minus voltage drop across the capacitor is what you have. Minus I2 of t dt is equal to 0. Now making the input voltage subject, this will be rho I of t plus 1 over c is I1 t minus I2 of t dt. This is, let's call this equation 1. Now for mesh 2, no, the other one was for mesh 1. For mesh 2, voltage drop across the same capacitor, moving in mesh 2 to be I2 minus I1. Zero T I use I2 of T minus I1 of T dt minus L the I2 of T minus I3 of T all over dt, then minus R1 I2 of T minus I3 of T is equal to 0. So you can either leave it as negative or multiply both sides by minus 1. Right hand side and left hand side of the equation by minus 1, you have 1 over C minus I1 of T dt plus L the I2 minus I3 of T, voltage drop across inductor, plus minus I3 of T is equal to 0. Let's call this equation 2. Equation 2. So mesh 3 now. Voltage drop across still inductor and resistor, and also across the terminals, the voltage, which is the output voltage, but it's not actually connected there. It's an open circuit, so it will be minus L di 3 minus I2 of T dt minus R1 I3 T I2 of T. This is equal to 0. So making the output, the voltage across the output terminal subject, this should be minus L minus I2 of T dt, and this will be minus R1 I3 of T minus I2 of T. So call this equation 3. So we know that, as I've explained it, from here we know that I3 of T is equal to 0. So substituting the value, I3 of T is equal to 0. Equation 1 becomes EI of T, the voltage across the input terminal, is equal to RO. This one doesn't change, it's still the same thing because it doesn't have current I3. the current I3. So dt for equation 2, this will become R1 I2 of t plus L the I2, because I3 now is 0, the I2 of t over dt plus 1 over capacitor C I2 minus I1 equal to 0, and 3, this will be equal to L di over dt plus R1 I2 of t. So the second thing now is to take Laplace transform. Take Laplace transform of equation 1, 2, and 3. So taking Laplace transform of the first equation, you have this plus minus I2 of S over SC. When you take the Laplace transform of 1 over C integral of 0 to t I2 I1 minus I2 dt. So R1 I2 of S plus L S, taking Laplace transform of the I over dt plus I2 of S minus I1 of S over SC is equal to 0. Now for third equation, Laplace transform of E naught of S, voltage across the output terminal, is this, and for the I over dt minus I2, this is I2, so plus R1 so now the initial conditions, assume the initial conditions to be equal to 0, which is just I2 of 0 equal to 0. So if you do that and substituting into all the equations, wherever you see I2 of 0, the new set of equations will be plus R equal to R resistor SC. Equation 2, I2 of S plus, substituting that value in place of I2 of 0 is what you get, plus minus I1 S SC is equal to 0. Then for the third equation, this should be equal to L S plus R1 I2 of S. So now we know that this is equation 1, 2, and 3. So from equation 3, make I2 of S subject of the formula from equation 3. So we can see that it's common, so we can factorize. From here, you have this is equal to I2 of S LS plus R. So divide both sides by LS plus R. You have that to be R plus SL. Yeah. So now, just like we did in the previous video, substitute this value I2 of S into equation 2. That's this equation 2, this equation here. So in order to get I1 in terms of the output voltage, the voltage across the output terminal, that's what I mean. So substituting, we're going to have I1 S so this will be I2 of S minus I1 of S. This will be over SC plus LS this will be I1 of S over SC, which is equal to minus, what am I writing? Minus plus I2 plus this I2, I'm not even supposed to write it, plus, this is what I'm supposed to write, SC times RO plus SL. So we can continue from here, plus L S RO plus SL plus RO1, this should be RO plus SL, so equal to 0. So we can make I1 subject from here. This will give you I1 of S. This is moving it to the other side of the equation. Now become positive. And then from here we can see that, let me just go straight. From here we can see that if you move this I1 of S over SC to the other side, you can see that this value for I2 is common to the 3, so we can bring it out. This should be this should now be now be 1 over SC 1 over SC plus S plus SL then plus RO1 plus R1. So now if we cross multiply this to make I1 subject, this should still be here, plus SL, then multiply through by SC, this should be 1 plus S squared CL plus SCR1. Now put this value of I1 S into, and also I2 of S, and also this value into this equation 1, this one here. This will be E1 of S plus equal to for the first, this will be RO1 plus SL, then 1 plus S squared plus S squared LC plus S R1C or SCR1, whichever you choose, plus this will be plus this. minus this is the value for I2 of S divided by SC. So simplifying further, from here we can see that exponential, sorry, this is not exponential, sorry. We can see that E naught of S over R1 plus SL is common, so we can bring it out. So bringing it out, you have this. Bringing it out and simplifying further, you are going to have this S R1 C plus R1. This is what you have. And dividing both sides by E or E naught of S, this is what you have. One over plus SL R plus S square RLC plus S R1 C plus SL plus R1. So taking the inverse will give you the transfer function also. So this is the transfer function R1 plus SL divided by R plus R1 plus SL plus R1C plus S squared RLC. So from here you can achieve this. From this. So this is the solution to this question. Don't forget to like and subscribe to this channel for more videos like this.